Now is it visible?
Yes,
Yes, sir.
sir.
Full screen.
Yes. Okay. Good afternoon to all.
Good afternoon.
Good
Good
afternoon.
afternoon, sir.
In the last class, we have started with the analysis of pin jointed structures. Okay. Okay. You have seen what is pin jointed structure and all. So what will be the connection for in the pin jointed structure? Which type of connections? It is
Hinged.
Pin, sir.
hinged or it is pinned connection. Okay.
Pinned.
So in terms of the reality, you can say it is single bolt or single rivet. If it is connected by the single bolt or single rivet, then that is a pin connected. Okay. So consider this is one beam, that is one member. This is one more member. So I have to connect this one. Okay. I have to make like this connection, and I have to put a rivet to this one. Okay. Rivet connected, so that it will become pinned connection. Okay. So whatever members here are there, these are the pin connection. You have seen space frame also. You have seen terminology, members and all. So what is the simplest form of perfect frame? What is perfect frame? First tell me, what is perfect frame? Okay.
Sir,
Now,
sufficient number of members to resist the load.
yes, the structure which is resisting the number of members required to resist the loads is sufficient. Ranika. That is called as perfect frame. Okay. If it is excess member, what it is called as?
Redundant.
Redundant. If it is deficient frame, less than the required,
कम होगा तो
that
deficient.
is deficient frame. Then what is statically determinate frame? What is statically determinate frame?
Completely analyzed, sir.
Yes, if the forces in the members of a frame is determined by using only equilibrium conditions. Okay? The forces in the members of a frame can be analyzed by using only equilibrium conditions. Then such a frame is called as statically determinate frame. Then what about a statically indeterminate frame? If the forces in the
Cannot be
members,
completely analyzed.
not completely, the forces in the members of a frame is not completely analyzed by the only with the help of equilibrium conditions, then that is called as indeterminate structure or a statically indeterminate frame. So you have seen pin jointed frames, determinate, indeterminate. So what is the formula for the perfect frame?
M is equal to 2j minus
Equal to J minus.
So up to so Sakti, how it has come? How this my m is equal to 2j minus 3? How it has come? So I will just take an example. Okay. Just I am taking an example.
वो members and joint वही ना sir?
Yes. What is this one? It is triangular shape. Okay.
Yes, sir.
Which type
Yes,
of connections? Which type of connections?
Hinged.
Hinged
Pinned.
or pinned connections.
Pin, sir.
So ऐसे सोचिए. So this is perfect frame. हमको पता है. Means number of members are sufficient to resist the loads. So I want to increase one joint. So I will take one joint. I have to increase. Okay. So I will increase one joint. So this is another joint. In order to connect this joint, how many members I have to draw?
2 members.
2 members I have to draw.
दो sir.
I have to draw 2
No
members.
member.
Correct, na? It means
Yes, sir.
number of additional members, number of additional joints is equal to additional joints कितना गए? 1 आ गए ना? Okay.
1.
So total number of joints is j. Okay, j minus 3 करने का. So that's why I will get the additional joints, that is equal to j minus 3. J minus 3. Is it understood? It means whenever you want to increase the additional joints, I have to deduct total joints minus 3. Total कितना है? 4. 4 minus 3 किया था, 1 joint आ गया. 1 is additional joints from the total joints. Is it okay?
सर
Yes,
वो
sir.
3 किस पर डिपेंड करेगा? वो ऑब्जेक्ट पे, मतलब अगर वो रेक्टेंगल होगा तो हमें 4 लेना पड़ेगा क्या?
See, I am not speaking of the rectangle. I am speaking of the simplest perfect frame. See what I am saying. Simplest perfect frame. which is the perfect frame? Simplest and perfect.
Triangle.
Triangle is the
Yes.
simplest and perfect. Correct or no?
Yes.
Yes,
Okay.
sir.
So अभी मैंने एक joint बढ़ा दिया, एक joint बढ़ा दिया तो so total number of joints are 4. Okay. So initially कितना था? 3 था. So it means additional member कितना आ गया? Joints कितना है? एक number. It means whenever you want, see, I will increase one more joint. So total number of joints are 5. Correct? Minus
Yes, sir.
3 करने का, minus 3 करने का. So additional joints कितना आ गया? Additional
2 आ
It
गया.
means whenever you want to find out the number of additional joints, that is j minus 3 करने का. It means additional joints मिल गया मुझे. Next, I want to find out the number of additional members. Additional members. So see, एक joint बढ़ाने के लिए कितने members चाहिए? Additional members?
2.
2.
2. Okay. I want to increase the 2 joints. 2 joints increase करने के लिए कितना members चाहिए? See,
4
I
member
want to
लगे.
connect कैसे करना? This is one member.
4.
This is one member.
4
and
member
this two.
लगे, sir.
4 members. It means double that of the joints. Additional
Yes, sir.
members is equal to
Yes.
double the additional number of joints. Is it correct?
Yes, sir.
Yes, sir.
So can I write
Yes.
additional members is equal to 2 times of additional number of joints? Additional number of joints is equal to 2
J.
times j minus 3. Is it correct?
Yes, sir. Yes, sir.
Yes.
Yes. So when you write this is, so total perfect frame is equal to m additional member is equal to 2j minus 3. So that is, you have to open this bracket. Total is equal to total members. I want to total members is equal to, so additional members are 2j minus 3. 2j 2 times j minus 3 additional members minus initial members कितना था? Initial इसमें 3.
Three था.
Initially it was 3. So solve this one. 2j 2 times of j. So just a minute, I'll change the color. So I will take this part. Okay, this part I will write here. So total members is equal to total members I want. So that is 2j minus 3. 2 times j minus 3. Okay, these are additional members. Plus initial members कितना था? 3. Initial members are 3. So open the bracket. 2 times of j minus 2 into 3. 6 plus
6
3.
plus 3.
So 2j minus 3, 6 plus 3, that is equal to 3. So
Minus 3.
this is m is equal to 2j minus 3. You don't remember all this derivation and all. Just you should remember perfect frame को condition क्या है? m is equal to 2j minus 3. Will you remember this one?
Yes,
Fine.
sir.
Yes, sir.
Yes, sir.
You don't remember all this derivation. Just आपको कैसे आ गया? Okay, that one I wanted to show. That's all. Okay. So कोई पूछे तो इसके लिए. So if the frame satisfied m is equal to 2j minus 3, then that frame is called as perfect frame. If it is not, then that is called as redundant frame or imperfect frame. In this case also, if the m is more than 2j minus 3, then it is redundant frame. If m is less than 2j minus 3, then it is called as 2j minus 3, the deficient frame. So इधर तक हो गया था ना last class?
Yes, sir.
Yes, sir.
See, so same perfect frame. Have you written this one? Perfect frame?
Yes, sir.
लिखा था ना? So that is m is equal to 2j minus 3. What is the m?
Members.
Number of members. J is
Joint.
Number of joints.
Joints. Number of joints.
Have you written this one? Deficient frame? Have you written?
No, नहीं सर लिखा है.
नहीं लिखा. Perfect
Yes,
frame लिखा है?
सर फिर भी नहीं लिखा सर.
परफेक्ट भी नहीं लिखा है.
एक मिनट.
नहीं सर.
Statically determinate, indeterminate लिखा है?
नो सर.
No, sir.
Okay, okay.
स्पेस फ्रेम लिख दे.
हाँ, ये हो गया ना?
Frame लिखा हुआ. हाँ.
Okay, okay. Okay, don't write this one now. Okay, write down all of you. Statically determinate frame. Statically determinate frame. A frame is said to be statically determinate frame, statically determinate frame, if it is completely analyzed, if it is completely analyzed by using conditions of static equilibrium, conditions of static equilibrium, full stop. Example, perfect frame. Example, perfect frame. Is it over?
Yes, sir.
Okay. Next step, statically indeterminate frame. Statically indeterminate frame. Statically indeterminate frame. A frame is said to be statically indeterminate. A frame is said to be statically indeterminate if it is not completely analyzed. If it is not completely analyzed by using the conditions of static equilibrium, conditions of static equilibrium. Okay, full stop. Example, redundant frames. Redundant frames.
Supervisor.
Okay, so what I will do, I will just explain all the things. Okay, I will upload this PPT. I have uploaded, no? Have I uploaded? Have you checked?
Yes, sir.
Okay, I have uploaded this one, I think. Okay, you just go through the slides because in order to dictate and all, it will consume time. I will explain all the things and we'll solve the problem directly. Okay, the theory part, you have to read it. Is it okay?
Yes, sir.
Okay.
Oh, yes, please.
So this one you have to write classification of frames and all the things, whatever there in this classification. Okay, the same thing is there in the words: perfect frame, deficient frame, redundant frame. Redundant frame पे क्या रहते हैं? Number of members are more than the 2j minus 3. Okay, perfect frame में m is equal to 2j minus 3. Deficient में m is less than 2j minus 3. Is this clear?
Yes, sir. Yes, sir.
So
सर नहीं
somebody
दिया
may,
सर शायद पीपीटी आप
हाँ क्या बोले?
इसका वो पीपीटी नहीं दिया सर शायद.
Okay.
नहीं दिया
So,
सर.
okay. I will upload it today, so you can check it. Okay. Okay. So as a this is important for the theory exam also. Okay. So just I will write here. That is important point. Okay. So in the theory exams, it is asked for the 3 to 4 marks question. What are the assumptions in the analysis of frames or trusses? Okay, first assumption, the ends of the members are connected or hinged. So it means whenever you take any member, the ends must be, it is connected or it is hinged. So always hinged members are, how it is shown? It is shown like this, pinned. Okay, it is always, it should be pinned. I say point karne ka. So when it is shown like this, it means it is pinned connection. Ends of the member should be hinged or pinned connection. Is it okay? First one.
Yes, sir.
Next,
Yes,
the loads act at the joints only. So whenever you take a analysis of the frame, always the load is acting at the joint only. At the joint only. Whether it is inclined or it is a straight line, I don't want. But the load must be acted on the joint only. It should not be act on the member. If it is acting on the member, then that is not a pin jointed. That will become rigid jointed structure. Is it clear?
Yes, sir.
Always it is
Yes.
acting at the pin joint joints only. This is important point. So we will solve the problem. The frame should be perfect. That is it should satisfy the condition m is equal to 2j minus 3. Then self weight of the members is neglected. See, whenever you construct any truss and all, always there will be some amount of self weight, correct? But in the analysis, we are removing that self weight. We are assuming the self weight is neglected. Then the members are having the same cross sectional area. Okay, all these members are there. All these members are having same cross sectional area. एक बड़ा एक छोटा वैसे नहीं लेने का. All are equally same size. Each member is subjected to only axial forces, that is either tensile or compressive forces. So each member is having इसमें एक force रहते हैं, that is force is due to applied force. That force will be either it is tensile force or it is compressive force. Okay, now आपको एक doubt आ गया. So what is tensile, what is compressive? So what is this one? This is joint, correct? Okay,
Yes.
if the
Yes.
force is coming towards the point joint, that is called as compressive force. Okay, if the force is going away from the point, that is called as tensile force. That is tensile. If it is going away, that is tensile. If it is coming towards the joint, then that is called as compressive. Okay, these 2 points you have to remember throughout the chapter, because always if it is minus, it is compression. If it is plus, it is tension. I said like them. That is, if it is towards the joint, then that is compression. If it is going from the joint, then that is tension. Always I will assume tension force only. Okay, tension means going away from the joint. Okay, if my answer is getting positive answer, assume the direction is correct, tension is correct. If I am getting answer is negative, it means assumed direction is wrong. I have assumed it is tension, but I am getting answer is negative. It means assumption is wrong. Tension is wrong. That should be compression. Is it clear?
Yes.
Okay.
Yes, sir.
All the members same cross section subjected to only axial force, either tensile force or compressive force. Then it is assumed that the whole frame is truss in equilibrium. Yes, whole frame is, it should be in equilibrium. What is the condition for the equilibrium?
Summation of f of
Summation of f is equal to 0. Summation
Fy is equal to 0 and momentum
Moment
point is
is
equal to 0. It means it
0.
should be perfectly equilibrium. Okay, these points should be remembered. So because in most of the MCQ questions also directly it is asked, self weight in analysis of the pin joint structure, self weight is option A considered, option B not considered, option C both, option D none, like this answer. It should be not considered. Okay, each member's cross section will be same, not same, varying cross section. ऐसे भी पूछ सकते. Okay, all these points are very, very important for the examination point of view. Okay, so you have to remember this one. Okay, nature of forces, I have told. Okay, what is this nature of forces? The nature of forces in the members of a truss or frames are, one is tensile force and one more is compressive force. If the direction of reactive forces are directly away from the joint or directing towards in each other in a member, then it is called as tensile force. See, so consider this is a joint. Okay, so this is a joint. Okay, so this is a joint. Okay, this is joint. The force is going away or towards? Going away, na?
away.
Away means it is tension from the joint. Okay, इधर एक joint है, इधर एक joint है. The force is going away or towards?
Away.
Going away.
It is tensile force. Okay, in between these two joints there is a member, correct? In member में the force is acting towards each other. In member the force is acting towards each other. Then that is called a tension force. Okay, see here in this figure में देखो. So इधर एक joint है, इधर एक joint है, correct? ये force ये joint को towards हो रहे. So this is which type of force it is?
Compressive.
Compression.
So इधर देखो, ये इधर joint है, ये force is going towards the point. It is compressive force. ऐसे भी So if the force is going towards the joint, that is called as compressive force. Or
Compression.
if you consider this is member, a member may, is it the nature of the force is it towards each other or going away from each other?
Away from each
Away
other.
from each other.
Away
Then
from
that is
each
called as
other.
compression. So here in this member, the arrow mark, is it towards each other or going away from each other?
Towards.
That is tension.
Towards.
Tension member. So it is going away towards each other in the member, but it is in the joint. In the joint it is away. In the joint it is away. In the member it is towards. Here in the member it is away, but in the joint it is towards. Okay, compression. This is tension. This is compression. This is tension. Okay, so in the compression going towards each other in the joint. Okay, in the joint it is towards the joint. In the member it is away. So some maximum time, if the force is coming it is positive, then that is tension, so tensile force. If the force is coming negative, then that is compressive force. Okay, you just remember this one. Is it clear, everyone?
Yes, sir.
Yes, sir.
Okay, so methods of analysis of frames. First one is analytic method and second one is graphical method. First, but for your exam and most of the times it is asked only analytical method. So in the analytical method, the method of joint and method of section, these are very, very important. Okay, method of one joint and method. So 10 marks problem directly it is asked by method of section or by method of joints in the offline papers. Okay, what is the difference between these two? Okay, method of section is what? Method of joint is count. Okay, so for this one, just concentrate at the screen. So what is this one? All of you. So this is truss, correct? This is truss.
Yes.
So this truss is made up of what? Members and joints. Is it correct?
Joints.
Yes,
Members
Yes,
and
sir.
joints.
Members
The
and joints.
forces are acting always at the joints. Always at the joints. The forces are acting always at the joints. When the forces are acting always at the joints, this force is going to transfer into the members. So hence the members are subjected to, they carry axial loads only. They carry axial loads, axial forces. The force may be either compression or tension. So my intention is I need to find out which type of force and magnitude of the force. Magnitude and its direction I need to find out. Okay, so how to find out? By method of joint and by method of section. Okay, so analysis of joints is done to find out the unknown number of members, unknown forces. So by method of joint is adopted to find out the unknown member forces. So I don't know the member force in this member, so I have to adopt this joint method. Then the truss is assumed to cut, analyze, and smaller sections to find out the unknown forces. See, first of all, method of joint is adopted when we want to find out the forces in all the members of the trusses. Okay, so if I want to find out the forces in all the members of this truss, then I will adopt a method of joint. Each joint को जाने का, equilibrium apply करने का, I will find out member forces. In case if it is given only selected member, see, he has given this member, only 3 members is given. So like this, only selected member is given, then we will prefer method of section. Okay, so this point you have to remember in the multiple choice question, in the oral examination, in your competitive exam also it is asked. Method of section is preferred in order to find out the forces in the member. Okay, forces in member in selected member only. Method of joint is adopted in order to find out the forces in member, all the members of a joint frame. Okay, so after finding the, first of all you have to find out the support reaction. See, first is used when we need, see here is when we need to find out the forces in all the members. Forces in all the members. See, usually when we need to find out the forces in particular or given members, which particular member is given, in that member only we have to find out by method of section. After, first of all, you have to find out the support reaction. Okay. After finding the support reaction, we need two equilibrium equations. That is sigma fx is equal to 0, sigma fy is equal to 0 at a joint. A point is very, very important. At a joint is very, very important. See, if I consider this point, so there is one force, there is one member, there is one member. Means there are only three forces which are passing. Either sigma fx is equal to 0 or sigma fy is equal to 0. But sigma m you are not supposed to take, because all the forces are passing through the given joint only. Okay, so whenever in the method of joints is given, you have to consider only two equilibrium conditions. First is sigma fx is equal to 0 and next is sigma fy is equal to 0. Is it clear, everyone?
Yes, sir.
Okay.
Yes,
So
sir.
now, in
Yes,
if it is
sir.
method of section is given. So in this case, so sigma fx is equal to 0, sigma fy is equal to 0, and sigma m is equal to 0. Because I don't know which type of members are. See, sigma there is in this section. So this is section he has taken. Okay, this is one member, this is another member, this is another member. Whether all the three members are passing through the given point?
Yes, sir.
No,
Pass.
it is not passing through the only one point, correct? It is different point. It means you have to consider moment about a point is equal to 0. Okay, if it is passing through the point, then that will not produce any moment. Okay, so in this method of section, there are how many equilibrium conditions?
3.
Three equilibrium conditions. Sigma fx is equal to 0, sigma fy is equal to 0, sigma m is equal to 0. Then the number of unknown forces in a member should be 2. So in the method of joints, so whenever you select a joint, in the selected joint, how many number of members are connecting, that is not required, but how many unknown members are there, that is important. Maximum number of unknown members in the method of joint is only 2. Why only 2? Because I have only two equilibrium equations. So maximum is I should have only two members, two unknown members. See, in this member, in this joint, the joint is connected how many members? How many members? 3 members. Among these 3 members, if you want to apply the method of joint, one member's force should be known. आपको एक member पता रहेगा value. Then only you can find out the other 2 member forces. Okay. In case of method of section, the number of unknown forces should be 3. So because there are 3 equilibrium equations, you can find out 3 unknown members. Is it clear, everyone?
Yes, sir.
Yes, sir.
First is, that is, when you apply when you find the number of unknown members, all the members at that time you will prefer method of joint. See, if it is selected member is given, method of section is adopted. Next, number of equilibrium equations in a joint, that is 2. In a
2.
frame, in method of section, that is 3.
3.
Okay. Then number of unknown forces in each joint is there is 2. Okay. In the method of section, there will be 3. Is it clear difference?
Yes, sir.
Yes, sir.
So method of joints. The method of joint utilize the force equations and equilibrium. Okay, don't worry. So each joint is given. So that force is given in the member. We have to find out the member forces. See, in this section method, he has taken cut and we have to find out member forces. So procedure for the member method of joints. So we will take procedure and we will take the problem in the next class first. Okay. So how to find out the method of joints? First of all, think that there is a truss is given. Okay. Two plain truss is given with loaded and with support conditions. Either it will be pinned hinged end support or roller support. Okay, support is given. Assume the whole truss to be equilibrium. First of all, you should assume that whole truss should be in equilibrium. Find out the support reactions by applying usual equilibrium conditions. Okay, already you have studied how to find out the equilibrium conditions. You have studied now for the beam. When the beam is subjected to loading, how to find out
Yes,
the
sir.
equilibrium conditions, you know, support reaction.
Yes.
So assume frame is in equilibrium. Assume find the support reaction. First method is you have to find out the, see, if you are not able to find out the support reaction, then you cannot solve this problem. That's why you should be perfect in finding the support reaction. Then select the joint for the analysis where the number of unknowns is only 2 in generally at the support. The use sigma fx is equal to 0 or sigma fy is equal to 0. Okay, so always you have to select a joint. You have to select a joint in which the number of unknown should be 2. आपके सब्जेक्ट just a minute. Okay, so it was due to connection problem. Is it visible screen?
No.
No, sir.
No,
sir.
No?
Yes.
Visual.
Yes. Okay. Because of net connection. Okay. First of all, it should be in equilibrium. Okay. Next method, next step is you have to find out the support reaction. Support reaction. Next is you have to select a particular joint in which there should be only 2 unknowns. Okay. See, in this joint, how many members are connected for this joint?
2.
See,
Hey.
total.
Two members.
Huh? How many members are connected? 1, 2, 3, 4.
4 है, sir.
4. So,
Four.
but among 4 members, how many are unknown in method of joints? Maximum is there should be 2 unknowns.
2.
Because I have only 2 equilibrium equations. Other 2 should be known. मुझे पता रहने का. नहीं तो क्या करने का पहले? You have to apply method of joints to this joint first.
कॉर्नर से लेने सर.
हाँ, इधर से. So इधर कितना मेंबर्स है? स्टार्टिंग से 2 मेंबर है, दोनों अननोन नहीं. So you have to find out this one first. Then you have to go to this method, this joint. इसमें कितना है? 1, 2, 3 है. Among 3, this is
3
known.
member.
This is known. So you can find out this and this. Correct? Then you can come to this point. Among this joint, so how many members are connected? 4. Among 4, 2 are connected. These 2 are unknown.
Yes,
you
sir.
can find out this one. समझ में है ना? How to proceed?
Yes, sir.
Yes.
Yes, sir.
Always you have to select the first joint is only the joint is connected 2 members. Okay. Next, consider the next joint for the analysis where the number of unknowns is once again 2 only and apply the conditions of equilibrium. Find out the magnitude of unknown forces. Repeat the above procedure by moving the next joint until we reach up to the last joint. Okay, इधर से start करने का, इधर तक end करने का. Represent all the forces in a tabular format by including all the members, magnitude of the force and the nature of the force, either compressive or tensile. Okay. Then also represent the forces in all the members in the given sketch and of the truss. Okay. First you have to draw the tabular column. You have to write the name of the members, magnitude of the forces and its nature, that is tension or compression. You have to write in the tabular column. Then again you have to show that all the representation in truss. You have to draw the same given truss and you have to show the magnitude and its nature in the truss. Okay, that is how we have to do by method. Okay. So find out the support reaction. Select the first joint. The number of unknown members should be 2 or less. Draw the free body diagram of a joint. Assume the unknown forces away from the joint, that is tensile force. Use sigma fx, sigma fy is equal to 0. This should be sigma fy. Okay, sigma fy it is. If the sign of a calculated force is negative, that force would be compressive. If you are getting positive sign, that indicates assumed direction is correct, that is tensile is correct. If it is getting negative, that is you have to reverse it. Then don't make any changes in the magnitude or sign. Such a force is further calculation, and it is last step for the mentioning the compressive force. Repeat the procedure for the next joint until we get all the forces in the members. Okay. This is how we have to go through the method of joints. Is it clear, everyone?
Yes, sir.
Yes, sir.
We will take this problem and we will solve. We will find out all the forces in the members. Okay, AB member, BC, CD, DE. Okay, and BE, CE. How many members are there? 3 plus 3, 6, 7. Okay.
7.
So first
Seven.
you should check it whether it is a determinate or indeterminate. How to check? How to check? M is equal to 2j minus 3. Okay, so see, this is triangular shape, this is triangular, this is triangle, this is perfect truss. Okay, simplest form of perfect truss is that's triangle. Correct? This is always it is perfect one. So next you have to find out the method of joint. Support reaction find out karne ka next one. So this problem we will take in the next class. Okay, and we will study all the member forces. Is it clear? Okay? All?
Yes, sir.
Yes,
Okay.
sir.
Okay. So now we will stop here. So remaining this we will study. That is tomorrow I am having 1 to 2 lectures. Okay, I will continue tomorrow.
Okay, sir.
Yeah. Is there any doubt to anybody?
Sir, the PPTs.
Yes, yes. Today evening I will upload. If it is not uploaded, then I will upload. I think I have uploaded. I will check it once again. Okay. So just
Okay.
quickly go through the attendance.
सर
Ah.
ते लॅडरचं होमवर्कचं एक्झाम्पल तुम्ही ग्रुपवर देतो म्हणाले.
ओके ओके उसका सोल्यूशन चाहिए ना आपको? ठीक, आई विल नोट इट, नोट करते हैं. सो लैडर प्रॉब्लम और एक केबल का प्रॉब्लम. ओके, ये दोनों का सोल्यूशन अपलोड करते हैं. ओके, एंड
ओके
टुडे आई विल अपलोड एंड आल्सो योर पीपीटी आई विल नोट इट, आई विल पुट इट quickly. I will go through. I have important meeting.
नहीं किया सर अपलोड. आखिर में वो
Okay.
यूनिट 2 का पीपीटी है.
ठीक ठीक, I will upload together. Okay, no problem. Row number 7, row number 12, row number 20, $38, okay, absent numbers 7, 12, 20, 38. Okay, these 4 numbers are absent.
तो 64.
64 is also okay. 64. Okay, so we'll stop now. We'll continue in the next class. Thank you all.
Thank you, sir.